The big question for this segment is, what is the Anthropocene epoch and why does it represent an exceptionally high level of complexity? The idea that we now live in a new geological epoch, the Anthropocene, is very new, but it's powerful and illuminating. In its modern form, it was proposed by the Nobel Prize-winning climate scientist Paul Crutzen in 2000. Crutzen earned a Nobel Prize for studies showing that human-produced chemicals were destroying the thin layer of ozone in the upper atmosphere that shields the Earth's surface from the sun's destructive ultraviolet radiation. Through this research, Crutzen learned that in an industrial world, human activities could have a profound impact on the entire biosphere. In a 2002 essay, he listed many of these impacts. By 2000, atmospheric levels of the powerful greenhouse gas carbon dioxide were higher than they'd been for several million years, as a result of the burning of fossil fuels, the crucial energy source for modern industrial societies. Humans were also having a greater impact on the nitrogen cycle than any natural processes, largely through the manufacture of artificial fertilizers. We had transformed more than 50% of the Earth's surface. We were using half of all available supplies of fresh water and drastically reducing the area under tropical forests. And our activities were driving other species to extinction at faster rates than at any time in the last few million years. These impacts reflected the sheer scale of human activity. Human populations increased by 10 times in just 200 years, and human energy use increased by 16 times in just the 20th century. Now let's focus for a moment on energy to get a sense of the scale of these changes. We've seen that all complex systems depend on flows of free energy. If these are too small, the system is starved of energy. If they are too large, it may be shaken apart. This graph gives some sense of the huge increase in human energy use since the beginning of the fossil fuels revolution in the 18th century. What are the effects of such huge increases in energy flows on the complex structures of modern human societies? Crutzen argued that the scale of human activity represented an entirely new historical phenomenon, one that was comparable with the major geological processes that had shaped the history of the biosphere over billions of years. The change was on a geological scale. So, he argued, it should be recognized by accepting that the Earth has entered a new geological epoch, the Anthropocene, and that the 10,000-year period since the end of the last ice age, known as the Holocene epoch, has now ended. Whether or not geologists decide to formally accept this proposal, the idea is immensely useful for anyone interested in understanding today's world. It encourages us to try to measure the scale of human impacts on the biosphere, and it encourages us to ask whether these astonishing changes are likely to destabilize human society and perhaps the biosphere as a whole. How stable is human society in the Anthropocene? What sources of resilience are there? Are there negative feedback systems that might stabilize the system, like a thermostat? Will climate science itself encourage the development of new and more sustainable technologies that can slow human impacts on the climate system? Can we slow our impact on other species? Or are there perhaps dangerous positive feedback systems that will cause sudden, unpredictable changes? For example, climate scientists warn that the loss of Arctic ice caps is darkening the surface of the Northern Hemisphere, which means that less sunlight is reflected and more is retained, which will in turn speed up the loss of Arctic ice caps. This module will end by asking about the possible impacts of climate change on living standards and health in different areas of the world.